All right, guys, welcome back. This is going to be our lesson for 10.7. Most of this is review. I'm just going to try and highlight a couple of the little trickier parts for these different definitions. So today we're talking about circles. Circles, if you remember, we can talk about the radius. So a circle, it's kind of a great definition. So when you think about a circle is the set of all points on a plane that are the same distance from the center point or from a given point. So every point along a circle is the exact same distance away. That's why we make them with compasses, because you can put the dot in the middle and then keep it at the same radius as you move around. Fortunately at home I don't have a compass, so you're stuck with my awful drawing of a circle there. A couple things about circles. So our center point is here. From the center to the edge of the circle is called a it's called a radius, and then a diameter is going to go the distance across the circle that goes through the center. So if we have a line segment that can go all the way across it and through the center, that is called the diameter. Okay, here's where it gets fun. So pi is the ratio of the circumference to the diameter. So if you can remember this definition, you never really need to memorize anything about circumference ever again. Because if we were to put this into words, we would say pi equals, because this is how we define it, circumference divided by diameter. And if you look at that, you go, okay, yeah, no, I see that. Ratios, we can write those as fractions. Cool, 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 cool. So if we take that then, that means though, if I look at this, I can also move this around and define our circumference, excuse me. That was my family outside. If I multiply each side by d here, if we multiply each side by the diameter here, you can see, all right, over here, diameter cancels out. And that means that the circumference equals the diameter times pi. Hey, that's like the circumference equation you had to memorize. That's exactly right. So, okay, you're like, wait, that's not exactly the same one. Well, if we remember that diameter is 2 times the radius, and we take that and we plug her in here, you'll see the other version that you'll see this equation is circumference equals 2 pi r, if we move those pieces around. So that's where that equation that you memorized long ago came from. Okay, I expect you to be able to use that as we've used other equations in different problems, and you'll have to do that in your homework. Okay, let's talk about the area of a circle. So if we look at this here, I want to break through this down because this is like really, really, really cool. So where does that area equation? You guys all know area is pi r squared. Yes, 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 we know that, Mr. Jacobs. Okay, here's one of the ways that they broke down that equation. So I just really like this as a proof. If we look at this, they're cutting the circle into pizza, or into a pie, although that's confusing with pi. Now, if we look at here, each of these pieces, the edge here almost looks like a triangle. And if I line up all of those triangles, I get really, really close to a parallelogram. And if I could cut this into smaller and smaller and smaller pieces, I could get it closer and closer and closer to the circumference part. Now, if you haven't seen the video yet, I highly recommend watching the other video that I posted about how pi equals 4, because it's using a similar process here, but it's using it wrongly and kind of showing how wrong that is. However, in this case, if we shrink this down to infinity, and each of these pieces, we get really, really close enough to a parallelogram where we can say, okay, yeah, I know how to do this, because the height of any one of these pieces is the radius, and this side plus this side is the circumference. And this is why I wanted to highlight this, because in your book it says circumference, circumference. Each of these is actually half the circumference, right? You can see how, oh, okay, it's like I took all of these here, And those are the ones I fit in on the top. And then all the ones on the other side, those are the ones I fit in on the other side. That means that it's half the circumference there. So to find this, then, we know that area of a parallelogram is base times height. Our height is our radius. 1/2 times the circumference. That's 1/2 times 2 pi r, which is pi times the radius, or pi r squared. And that's why area of a circle is pi times the radius squared. You should go ahead and copy that proof into your notes. It's in your textbook on page 535. But area for a circle, you knew this already, is pi r squared. So you're going to use both of those equations, and you're going to plug them in. Just be careful with your order of operations on these review practice problems. So you've done things like this before in the past. So your homework assignment for this, so this is a shorter video lecture. Your homework assignment is 10 through 18 even. Let me make sure that I'm looking at the wrong one. This is 10.7. Oh, it's chilly in my garage. Okay, 10.7 is the assignment. So you're not doing 10 through 7. Then we're doing 10 through 18 even. And then 20 through 25 all. 32, 33, and 34. All right, those should be some good practice problems for us all, and I hope you guys, I just wrote it all out and it wasn't under the camera. There you go, there's your homework. Sorry about that. I hope you guys are enjoying your time at home, and don't be afraid. All right, you guys have a great day.